Hello, I'm Craig Otto. Today I'm going to go through just some miscellaneous items for operational excellence. A lot of it will revolve around Kaizen and rapid improvement events, if you will. Basically, before I get into that, I'll just run through some different things that you might look at when you're implementing operational excellence. Um, Factory layout is a big player when you start talking about efficiency and basically a lean factory where you minimize the cost of material handling and how that material flows through the organization and the factory. And you also learn about how processes are connected or a lot of times disconnected based on just mapping out the factory layout. Some of the other things that the factory layout impacts is things like your visual management, safety. We talked about 5S in our other tools last week. Future expansion options, basically as the factory grows or as you get new business. So here's just some examples of a factory layout. A lot of times when you have a lot of work in process or a lot of inventory, you have to have a lot of different places to store that inventory, and therefore a lot of forklifts that move the inventory around, and you end up moving and transporting the product a lot more than is necessary versus taking it to the lean one piece flow process or cell, and it flows through that process and it flows right back out like you see on the right side. um, so that's just some things that you'll see. One of the easiest tools you can use is this factory layout. A lot of times it's called a standard work chart or spaghetti chart. It's all part of the standard work tools. A lot of times you'll use this in a Kaizen or rapid improvement event. Um, some people get hung up, depending on your culture, on using Japanese terms. Basically, the Japanese word Kaizen means Kai means change, Zen means good. So, good change. We call it rapid improvement events at our facility just because the military doesn't like using Japanese terms. It just works better for us. So, really, it's up to your culture and your organization of what you call it. But the bottom line is, you're trying to make incremental change to the organization to make it more profitable and satisfy your customers. Of course, all the standard foundational things like 5S or 6S, visual factory, standard work, those things need to be in place before you go out and do a lot of Kaizen. Um, you may also hear the term Kaikaku. That is more breakthrough success versus incremental success, and a lot of times you'll see that in Six Sigma projects. Some of the principles behind the event. Obviously, you want to have clear objectives. Otherwise, the team won't know. They'll flounder on what to focus on and what to attack. Um, Everything should be quick. You'll see that a lot of times it's all done within 1 week. Obviously, that's a lot of work to get done, but that's the goal. Um, and a lot of times it's chained to a value stream analysis, something that's driving that event to happen. As far as the team makeup, it should be cross-functional. A lot of times, a third of the team will be your production or your operation people. Then you have a third of your support that work in the area, and then a third that are actually may have the process knowledge, but they're not actually involved with the area. So that sort of gives extra brainstorming power there by having someone who's not familiar with the area. As far as the team roles, a lot of times you'll need a team leader. They're the ones that'll coordinate and direct the team, assign the activities, and they should have real good leadership skills. Um, I know for a while at our facility we had sub leaders as well. Basically, you're there to the sub leader could be the supervisor, but you're kind of using that sub leader to build them into eventually a team leader. And also, it's nice if they are over or in charge of the area, is if they're a leader, then they sort of want to make that change last and they take ownership in it. And then the team members they're there to identify waste, try out new solutions, and get the changes implemented. Here you can see that it's basically a rapid improvement event or a Kaizen event. It's a 5-day event. First day, especially early in your transformation, you'll spend a lot of time training people to see waste and success and different things like that. Day 2, you'll actually go out to the floor, review the current layout, map it out just like you've seen in the plant layout or facility layout. Do time observations, build bar charts. You'll learn about those tools later. Identify the wastes, and day 3, basically going out, making changes, testing, evaluating, trying to standardize. And day 4, you should have a good idea on what the results are, what the changes need to be. You should be communicating those changes and making it a part of the new process. And then, of course, day 5 is a report out to leadership on all the changes that you made. Jidoka, it's automation. Basically, it's kind of automation with a human touch. Basically, it's stop. Don't pass a defect down the line. Basically, it means stop production so that production never has to stop. You're not passing a bad product down the line. You're trying to prevent it. You're trying to fix it right now. And the earlier you can detect it, the better. Quality at the source is a principle. It's very important. Andon is a type of basically automation. You want to detect and stop. A lot of times, I know in our discussion panel, inspection comes up. Really, inspection is only 80% accurate. You kind of want to take away the human inspection part of it as much as you can and make it a part of the process. I'm a big proponent of building quality in instead of inspecting it in. And what I mean by that is poka-yoke. And basically, you're fail-safing the process. You're mistake-proofing it. You're not allowing the error to occur. That way, it kind of inspects itself. And originally this was kind of originated from Shigeo Shingo as part of the Toyota production system. But just some examples. You can't remove a car key from the ignition switch if the transmission's not put in park. And that's kind of an air proofing in an inspection all at once, because humans forget, and inspection's only 80% accurate. So, 1 out of 5 times you could be trying to pull your keys out and the car's in drive. So basically what they did was they made it impossible for that error to happen. They built quality into the process versus inspecting it in. Same with this shows some of the age of this presentation, but like a normal 3.5 floppy disk, the one corner is shaped in a way that you can't insert it upside down. You can't make the error. Or in a lot of cases, you have jigs and fixtures that will only hold the part in one way so that you don't orient the part incorrectly. These are all building quality into the process. It automatically inspects it without having to inspect it. Here's just some other techniques. Obviously, you have prediction and you have detection. Some things shut down, some things control, some things warn. And like with cameras, they will not function when there's not enough light to take a picture. And then some laundry and dryers have a device that shuts them down whenever they're overheating. And that's a detection. Unleaded fuel pumps, you can't fit those into the leaded gasoline tanks. And that's just another way of preventing errors from happening. The file cabinet drawer will not open if another drawer is already open. That's all preventing things from happening. Many cars have warning systems. That's an example of prediction. Smoke detectors, providing a warning that smoke has been detected and there's a possible fire. All of these things are trying to airproof a process or build quality into the process. Moving on to total productive maintenance. Basically, it's a company-wide effort to check and keep a strong life cycle of your equipment, and it involves every employee. The goal is really to minimize downtime due to maintenance and to maximize machine uptime. And automation is a big part of that, where the operators are involved. And yes, they inspect, but they also put a lot of poka-yoke in place too to keep the equipment up and running. A lot of these, rapid improvement events, total productive maintenance, a lot of these things that we call lean manufacturing, it can achieve many great results. 75% reduction in inventory, 90% reduction in lead time, 100% or greater improvements in productivity, less than 500 parts per million in defects. And if it's done right, you get improved morale. If it's not so right, then you get less morale, but we'll get into that. That's why you're in the program. You should see a lot less safety accidents as well. So, and just one last slide here. We are trying to maximize value. A lot of times, your process will only be, 5 to 10% value added, where you're actually changing the form, fit, or function of the part. And then there's other things that, at the time, some quality checks are necessary. You don't have enough quality built into the process yet. You don't have enough airproofing where you have to do these quality checks. But the goal should be to reduce the quality checks and build quality into the product. Design ways into the process that inspects it automatically, so you don't have to have someone check it, because people are only 80% accurate when inspecting. And then, of course, you still have all the other things that are just pure waste, and the more you can eliminate and reduce that waste, that's where your cost savings comes from. So with that concludes the presentation on the different miscellaneous tools.